Good day and welcome to my class on logarithm. This is GER Hub, Genesis Educational Research Hub. Please smash a like on the video and let's begin this class on logarithm. So what is the logarithm of a number is where we shall begin from. What is the logarithm? What is the logarithm of a number? So we shall begin from here. Okay, so that will be the first thing we shall discuss in this class on logarithm. The next thing we shall discuss in this class on logarithm are the types of logarithms. Okay, the types of logarithms. And thereafter we shall look at the next thing which I shall tag under the discussion conversion from logarithms to index numbers or index forms. Okay, so thereafter I would finally, in this particular lecture, I will look at the laws of logarithm. Now, the only thing I will not be discussing in this particular lecture, but I will be saving for the second part of this lecture, will be to prove the laws of logarithms and to solve examples on logarithms. So, even though we shall be looking at the several types of logarithms, the focus of this particular lecture will be on theory of logarithm, as you shall see. Without much ado, let us begin. So let's start with the first item. I shall call this 1, I shall call this 2, I shall call this 3, my third item, and I shall call this 4. So let's start with number 1, which is what is the logarithm of a number. So mathematically we shall define the logarithm of a number as follows. So I'm going to say the logarithm of a number, say x in a given base, say a, let's rather call this y, please. So the logarithm of a number y in a given base a is the number x to which one must raise the number a to get the number y. I'm going to repeat that definition again. Okay, so again, what are we saying? I'm saying that the logarithm, what we call the logarithm of a number, say y, is in a given base. Okay, so one thing I must establish before we go into detail in this definition is that when talking about logarithm, please take note that you cannot talk about logarithm absent a base. So logarithms are always taken in what we call the base or a base. Okay, so if you are to define the logarithm of a number, say y, in a specified base, say a, that logarithm, what we call the logarithm, is another number we call x. But this number has an attribute. If this number x must be the logarithm of y in base a, then it must satisfy this condition. This x must be the number to which you would raise this number a to get y. Now, mathematically, this definition translates to the following. Mathematically, we have logarithm, we use log for short, logarithm of y, this number here, in a given base a equals x. So we write it in this form. Now, what this means is that if the logarithm of y in base a is x, then this implies that a raised to power x will give y. Now, if you followed my class on indices, you will remember that this number x, this expression a raised to power x for y, we had called it the index form of y. And you will remember in that class on indices, I told you guys that x, this number x, could be called the power, the exponent, the index, or the logarithm. So please take note of the fact that a raised to power x is the index form of y, means that x is the logarithm of y in base a, what you have here. Okay? Now, that brings me to the next thing I want to discuss. Now, let us take few examples on this. So, looking at what we were to discuss, what is the logarithm of a number? We have just answered this question. But to make it very clear to you, I'm going to bring this. So, question is, what is the logarithm of 25 in base 5? The logarithm of base 5, the logarithm of 25 in base 5 will be any number you can think of to which you will raise 5 to get 25. And the only number that comes to mind that satisfies that condition is 2. So why is the logarithm of 25 in base 5 2? It is because 2 is the number to which 5, this base, must be raised to get 25. Another question is this. Logarithm of 64 in base 4. What will the answer be? You guessed it right. The answer would be 3. Because 4 raised to the power of 3 will give 64. And you can clearly see the relationship that 5 raised to the power of 2 gives 25. Means that 2 is the logarithm of 25 in base 5. And the next thing again, in this one, you would clearly see that 4 raised to the power of 3 gives 64. Means that 3 is the logarithm of 64 in base 4. Because 4 times 4 is 16, and 16 times 4 would give you 64. So this again is true because 5 times 5 will give you 25. So that answers the question, logarithm of a number. What is it? It is the number x to which a, the base, must be raised to get the number y. So it is as simple as that. Now, I have just stressed the fact that for you to talk about logarithms, you must talk about the base. Okay? So the question is, what are the types of logarithms? What are the types of logarithms? So logarithms are categorized into 3 types. And when classifying logarithms, please take note that logarithms are classified based on their base. So I'm going to put it here. Logarithms are classified based on their base. Okay? Logarithms are classified based on their base. Based on their base, it now amounts to the following. So there are 3 types of logarithms. So the first type is called common logarithm. Common logarithm. Okay? The second type is called natural logarithms. Natural logarithms. Or you could call it Naperian logarithms. Naperian logarithms. Some people may want to call it hyperbolic logarithm. It is your choice, but this particular logarithm, in some textbooks, please take note, all these are names. I prefer students going by what they mean instead of holding on to the names. So please, in some textbooks and in some materials on the internet, you may find people calling this logarithm, common logarithm, the same as natural logarithm. So I would want you to de-emphasize names but focus on what they mean. So if you find a material calling common logarithms natural logarithms, I don't think they will be wrong. It is just a name. If that material is to be wrong, then look at what they defined it to be. Okay, so please take note of that. Now the third category of logarithms are the logarithms we would categorize into what we call theory of logarithms. Okay, so that is the first story I would want to say under this. So there are 3 categories of logarithms classified as types. Okay, common logarithms, natural logarithms, also known as Naperian logarithms or hyperbolic logarithms, theory of logarithms. So when do we say we are dealing with common logarithms? When you deal with the logarithm of y, like we said earlier on, and the base a is 10. So if a, the base, is equal to 10, then we are dealing with common logarithms. So what are we going to say here? Logarithms of numbers, common logarithms are logarithms of numbers, in base 10. So if you tell somebody you are dealing with common logarithms, you are simply telling the person you are dealing with logarithms of numbers in base 10. Now, moving on from that, you would clearly see another thing that is important to note about common logarithms. Please take note, guys. When you are dealing with common logarithms, you don't need to necessarily write the base. So if you see me write log 5, nobody needs to tell you that I am dealing with common logarithm, because in common logarithms, you don't necessarily have to write the base. Once you don't write the base, we assume by default in mathematics that you are talking about common logarithms, because we would assume that your base is 10. So if not in base 10, that is if not common logarithm, please always endeavor to indicate your base. Okay, always endeavor to indicate your base. So logarithms of numbers in base 10 are called common logarithms, and usually or oftentimes when we write the number whose logarithm we want in base 10, we only put the log of that number without putting 10, just to tell you that we are dealing with common logarithms. Okay, so if you see me write log 27 without putting the base, just know I am actually referring to log 27 in base 10. So these are regarded as one and the same thing. Let's move on to natural logarithms. So what are natural logarithms? They are logarithms of numbers. They are logarithms of numbers in a base called e. Now, the base called e, please take note, the base called e is actually a constant, an irrational number. Okay, so please take note of that. Now, for e, the number e is approximately, this number e is approximately 2.718 and so on. So please take note of that. Now, once you are dealing with the logarithm of a number in base e, that particular logarithm is called the natural logarithm of the number. Okay, so if I'm taking the logarithm of base of y in base e instead of 10, I will be dealing with the natural logarithm of y. So the natural logarithm of y in this case will be log to base e of y. Okay, it will be called the natural logarithm of y, or the Neperian logarithm of y. Now, that means that I could have log to base 27 of e. I could have log to base e of 27 rather, and log to base e of 5. Now, please take note, just the same way I told you earlier on that when dealing with logarithms in base 10, you don't need to write the base 10. The same thing applies to the logarithm of numbers in base e. The only difference is that there is a notation. So instead of writing log to base e of y, we use the symbol ln to represent log to base e. So we simply write lny. This lny is pronounced as ln y. So we pronounce this as ln y. Now, if I don't want to write log to base e of 27, I will simply write ln 27, and this is pronounced as ln 27. If I don't want to write logarithm to base e of 5, I'm going to write ln 5, and this is pronounced as ln 5. So that is another type of logarithm. Please take note. Then moving on from that to the next theory of logarithms. So we have classified logarithms into the first part by the base 10. We have classified it into the second part by the base e. Now, this is when a is equal to e. Now, what about when a is not equal to 10 and not equal to e? If a is not equal to 10 and not equal to e, that is, you are dealing with logarithms of numbers whose bases are not 10, that is not common logarithms, whose bases are not e, that is not Neperian logarithm or natural logarithms, then we classify all those other logarithms under what we call the theory of logarithms. So I'm going to put here that logarithms of numbers in bases other than 10 or e are called theory of logarithms. Okay, so we put all the logarithms of numbers whose bases are not e or 10 under what is called theory of logarithms. So that being said, let us go to my third discussion. My third discussion is converting numbers in logarithms or logarithmic form to index forms. I have already done that earlier, but I'm going to emphasize this quickly. So let us see. As number 3, so if I have a number log y, the logarithm of a number in base a, then to convert this, let's say the logarithm of y in base a is equal to x. Now, this form of y is called the logarithmic form. It is called the logarithmic form of the number y. Okay, the number y. Now, you could convert from the logarithmic form of a number, that is this form, to what is called the initial form or index form of the number. You can convert. So how do we convert? All you have to do is to follow the definition. The definition of logarithm of a number y says that the logarithm of a number y in a base a is x, means that x is the number to which a, the base, must be raised to get y. So that means that if I have logarithm of y in base a giving me x, then a raised to power x is equal to y. This form of writing y is called the initial form of y or the index form of y. Okay, some people will call it the exponential form of y. So they all are referring to one and the same thing. So you can actually convert from logarithmic form to index form or initial form, and you can convert from index form back to logarithmic form. So you can actually move two ways. So if I have log of 25 to base 5 equals to as the logarithmic form, I can move from this down to this, and I would call this 5 raised to power 2 equals 25. So the logarithmic form of 25 in base 5 is 2, while the logarithmic the index form of 25 in base 5 will be the logarithmic and the index form, of 25 will be 5 raised to power 2. So I can move this other way by reversing the process. Okay, so converting from logarithmic forms to index form is very, very simple. Let's try some. So if I have 4 raised to power 3 equals 64 as my index form, then the corresponding logarithmic form will tell me that log 64 in base 4 is equal to 3, and that is it. If I have 100, log of 100 in base 10 equals 2, then it means that the index form corresponding to this will tell me that 10 raised to power 2 is equal to 100. So it is that simple. Let's try one more. So if I have log of 81 in base 9 equals 2, then it will mean that the index form will be 9 raised to power 2 equals 81. And if I have lastly the logarithm of 625 in base 25 equals 2, then it will mean that the corresponding index form of this will be 25 raised to power 2 equals 625. So this is just what it takes to move from logarithmic form to index form, and from index form to logarithmic form. But this is called the index form of y, while this is called the logarithmic form of y. So please take note. The logarithm of y in base a is the number x to which a must be raised to get y. And the index form of y is an expression as this, such that a, the base, carries an exponent x, such that a multiplying itself x times will give y. So please take note of that, and let us move over to number 4. So what then are the laws of logarithm? So let's look at the following laws that we shall be proving in my next class. So this is the 4th discussion under my introductory class on logarithms. So what are the laws of logarithm? Law number 1 may be called the addition law. Please take note, I don't deal with the names of these laws, I deal with what they mean. So please, this name may be different in another textbook or material you look at. Never mind, provided it communicates the same thing. So let's see. So if I have the logarithm of a number a in base a added to the logarithm of a number b in base a, then by the law of logarithm, this addition law of logarithm, then my result will be the same as multiplying these two numbers in that base. Okay, so log a to base a plus log b to base a will be equal to log a times b to base a, and that is the law. Number 2, there is another law you may call the subtraction law of logarithm, and this law simply says that if you have log a in base a minus log b in base a, then the law says that your result will be in base a over b, the log of a over b in base a. So this translates to this and this translates to this according to that law. Then this law, the next law, is the law I would call the law of identity or same base. Okay, identity. Now this law simply says that the logarithm of a number a in that same number as its base will give you 1. Okay, so that is the law. If you take the logarithm of a number a, okay, if you take the logarithm of a number a to itself as base, it will give you 1. So please take note of that. Then the logarithm of 1, the next law is the law, the law we call unity law. Okay, so this law is simply saying that if you take the logarithm of 1 to any base at all, the result would always give you 0. The logarithm of 1 is 0. Now when it comes to proving these laws, I'm going to show you how these laws relate to the laws of indices. Okay, they all can be proved using the laws of indices. Provided the laws of indices are true, then these laws are true. Now let us move to the next law. Law number 5. This law I'm going to call the law of power of the base, or the law of power of the logarithm. So I'm going to have, if you have a number a in a base a, and you want this particular number a carries a power b, then this law is telling you the result will give you b. This b would multiply the logarithm of a in base a. So this law is called the law of powers. Okay, the law of powers. Now there is another law in number 6. Now whereas this one talks about b being a power to a, the number whose logarithm you want to find in base a, the variant is saying that the logarithm of a, that is a number a, in base a raised to power b will be equal to 1 over b logarithm of a in base a. Okay, so this law is called power of the base. So this name may be different in a text you read. This is called the power of the base. Okay, now the next law we shall be looking at is law number 7. So in law number 7, this law we are looking at is called the law of change of base. The law of change of base. Sometimes in different laws of in different problems on logarithm, you may have a need to change the base. Okay, in trying to simplify, this law is simply saying that if you have a number a in a base, say a, this result, if this problem is complex to solve in this form or simplify in this form, you may find it easier to solve if you change the base from a to b. And the law is saying if you want to change the base, then the log of A in the new base will be divided by the log of the former base in the new base. So this law is called the law of change of base. Okay, so we shall be proving this law in my next class. So thank you very much for watching this video. Until some other time, do have a lovely night rest. Please smash a like on the video and endeavor to subscribe to the channel if you haven't subscribed. Share this video and drop your good comments, and endeavor to become a member of my community by clicking the join button and picking what level you can join my YouTube community with. So thank you very much. Good night.